Welcome to massive open online course on chemical process intensification. So, we have discussed a lot of information about the chemical process intensification up to module 11. Now, in this module, module number 12, we will discuss something more about that process intensification, and in this module will be regarding the microprocess technology for process intensification, and in this lecture under this module we will try to discuss something about what is that microprocess technology, and also how that microprocess technology will be considered for the process intensification, what is the direction of that process intensification of this microprocess technology. Now, before going to that, we have to know the terminology for this microprocess technology and what is the definition of those terminologies which are being used for that microprocess technology for the process intensification. Now, if we talk about that microprocess technology, you will see that there will be a certain process in chemical engineering where you will see that the process of different chemical engineering like adsorption, absorption, even reaction system, that is done in a continuous flow system, and where that flow system will be controlled in such a way that it will be flowing through the micron size conduit, where getting some special advantages whenever that flow will be flowing through that micron size conduit. Now, if you consider that suppose chemical synthesis and also other processing by that application of continuous flow systems, it is sometimes called microfluidics, and which will be actually regarded as chemical microprocess technology. And this microfluidics is actually a science by which that fluid flow phenomena will be manipulated and controlled, usually in the range of microliters, like 10 to the power minus 6 to the picoliters of volume in networks of channels with dimensions from that is 10 to hundreds of micrometers. Here in these slides, we are showing one microfluidic systems where you will see that some fluid will be entering through that inlet and it will be passing through the some micron size channels, and it will be coming out, and during that flow there will be certain advantages of that fluidics flow through these dimensions of these micrometers, and that will be discussed that is successively there in the lecture. Now, this is the things that we can say that through that volume of that very small amount like microliters, that will be actually considered whenever any chemical synthesis or process to be done in that micron size channel, and based on that micron size channel when a reactor is being procured, it will be called as micro reactor. Now, there will be certain specific application of those microfluidic systems, even micro reactor system based on this micro channel based micro reactor. And the reactors that is being used for these objectives are actually comparatively very small, and also it can be called as chip based reactors, or it is sometimes called that micro reactors. And if the micro reactors having a microstructure zone, there may be that multiple number of micro channels will be arranged in an array, or some other provisions, that mechanical provisions or some other that way for arrangement of that micron size conduit or micron size devices in a particular that zone, then it can be regarded as a better name of microstructure reactors. Here see, there are several different types of micro reactors are shown in the slides, that is taken from that website. It is given here. So, this is one of that micro reactors, this is glass micro reactors, this is channel based micro reactors, where micron size channels are actually that procured in a glass system, so that whenever flow in a particular process systems will be coming into the reactor and it will be coming out, during that flow through the channels there will be a gaining some process intensification. So, micro channel based process intensification will be here in the reactor, where this procured based on that micro channel. Here some other synthesis of the chemicals through this micro reactors like this type of, where the channels will be micron size, and it will be designed in such a way that there will be a micro mixing inside that channel, just making a that even grouping or some other fashions of that micro channels to get that intensification of the mixing, and also intensification of the yields of that reactions that is being done for the chemical synthesis. And here also there is another micro reactor systems, where you can say that there are array of micro channels are placed in such a way that systems are being actually scaling up from that one channels to the hundred of channels there, even more than that, and it will be procured in such a that successively or consequently you can say, or parallelly more than number of reactors, micro channel based reactors will be procured, so that you can get that more yields and also that more efficiency for that chemical synthesis. That may be in terms of residence time of the reactor, even less amount of solvent using, even some other process intensification aspects that will be applied for that micro reactor system. And also the execution of this chemical process through this micro reactors or micro channel based reactor is very important in that, because there is a volume is very small, that the execution of that chemical process inside that small volume, typically inside that channels with the diameter that is less than 1 millimeter, or other microstructure with sub millimeter dimensions, here is very that complex, and you have to precisely devise that micro reactor just by considering that micro channel array having that micro mixing and even other mechanism, so that there will be a intensification of the process there. Now, sieve based reactor is also one important aspects of that, basically the same name that of micro reactor. In this case that it will be dealt with operation of a large number of parallelized micro channels there. So, it is called the chip based, that is here this is one chip where that micro channels will be arrayed in such a way that there will be through that channel that liquid will be flowing, and there will be a application of this type of liquid flow through that micro channel, maybe for the chemical synthesis, even absorption systems, they are for getting that more interfacial area as well as some other advantages that will be discussed. Now, question is that is there any difference of micro reactor and the chemical microprocessing or not? In earlier stages there is that as per earlier definition, that microprocessing, that actually it is regarded as the technology driven definition of micro reactor. In that case, that micro reactor accordingly is termed a device that is at least that partly made by microfabrication, or you can say that modern precision engineering techniques. As a result, that micro reactors have some millimeters internal dimensions. Now, present definition will be something different from that. As per that present definition, what is that? It is considered that this micro reactor will be a casing for performing reactions that is designed based on the flow patterns with characteristic dimensions, that will be mass below that of conventional apparatus, typically below the sub-millimeter range. So, there are two types of definition, one is technology driven definition, another is application driven definition. Earlier is that the definition of that microreactor is basically based on the technology driven definition, whereas nowadays this microreactor is defined based on the application driven definition there. And is that synonymous with simply using a microreactor for an application, or some other terms will be used for that. If you that is replacing that conventional equipment by the novel microreactors, then what will happen, whether it should be suitable or not? No, it is not there, because that chemical microprocessing, it is generally based on that process design in a unit cell before manufacturing new selecting existing microprocessing equipment that is composed of a magnitude of cells. This results in having tailored processing equipment at the microflow scale. So, this definition actually given by this Hessel et al. 2005 in their books, that they have actually stated that no, there should not be that synonymous of this simply using a microreactor for an application that is replacing that conventional equipment by novel microreactors. So, this processing, chemical microprocessing actually should be based on that process design in a particular unit cell before actually manufacturing new or selecting existing microprocessing equipment there. So, in that direction, that you have to define that how chemical microprocessing will be there. So, these things very important, that you have to remember that how that chemical microprocessing is actually different from that micro reactor system. Now, basis of process intensification, very important that you are going to use that microprocess technology for that chemical process intensification or other things. So, in that case, what should be the basis of that process intensification? Now, a microreactors, especially those having large throughput, may fulfill the criteria of process intensification, and in that case that process intensification devices can be regarded as a branch of process intensification based on that chemical microprocessing. And in that case that process intensified devices usually cannot be referred to a unit flow description as given for microreactors, since they are dealing with non microflows. Also you can say that process intensification will rely on a novel specially designed reaction equipment of the larger scale. So, that is why this should be the basis for that microreactor, especially those having large throughput, may fulfill the criteria of process intensification. Now, in this regard it is very important whenever you are going to apply this microprocess technology just by developing that process intensified device, then you have to think about it that not only just using the single channel, it will not be actually economic, or you can say that it will not be that large scale application. So, in that case you have to think about that numbering of that channels. So, instead of one channels, maybe more than 100,000 channels will be there, even more also, that based on that process intensification specific application also. Now, a favorable feature of many microflows is regularly or symmetry. In that case the modified that microreactors based on that just having that more than one channels will be there. So, in that aspects, if you are considering that microflows to be in regular fashion or symmetry, so in that case that manifold repetition of that internal flows structure to be considered, and that should be considered as a constituting element there. So, this relates to the flows in channels with channel arrays parallel to each other. So, this flow symmetry that will be concerned the flow within one micro channel, that may be scaling or numbering up to a several numbers to get that same fashions of that symmetry of the flow. And whenever you are numbering up that channels, you will see that just considering the same symmetry, you can get that parallel symmetry of that flow, and there may be you can increase that residence time, even also for that yield of the process will be increased for that. And also successively you will see that there will be a flow pattern changing from that particular single phase to the slug flow, and then there will be intermittent and then slug and then churn there will be there. And also in that case if you are using more than one channels, that things also can be procured if you are array that channels successive one by one and parallel in parallel way. But this is the advantage that you may not get that radial extension of the flow when you are using that micro channel. But in case of conventional channel that is more than 1 millimeter, there may be that there will be internal circulation of the flow, there may be axial evolution, but whenever you are getting the slug flow, surrounding the slug flow there will be some other circulation, even some droplet formation, even there will be some it is called stagnation zone at that end of the slug flow and at the end of the slug there in the channel. So, the flow symmetry, to get it through the channel, you have to that consider not only that single channel of micron size diameter, it may be that parallel even with more than one channel there. And also microflow processing, the repetition of that unit cell, that is one channel to that 100 channels typically, not only holds at the laboratory scale, that may be be applied to the smaller to larger even production as well. So, this is achieved by just numbering of the elements, that is by multiple repetitions of the small precisely structured regions there. So, that is called that numbering of, that is from one channel to the up to desired number of channels there as per process application. Now, there may be two types of numbering up, one may be that internal, another may be external numbering up. In case of external numbering up, the connecting of the many devices in a parallel fashion, that will give you that external numbering up. But in a single reactor, there may be that more than one channels will be arrayed, but this external means here connection of many devices here they are in a parallel fashion. It is shown in this figure as that here one device, another device, another device. So, more than here one devices, here typically 4 devices are arrayed connected in a parallel fashion. So, this is called external numbering up. Whereas, internal numbering up it will give you that functional elements only rather than of the complete devices that will be connected parallelly. In this case, the functional elements are grouped in a new way, usually as a stack and compassed in a that new housing there. So, here this as shown figure in the slides, that is there, that how you will see that internal numbering up is there. And some features of that chemical processing which favor that choices of either external or internal numbering up. Now, that maybe you will see that if you are using that external numbering system of that micro devices. So, in that case you may have that low degree of parallelism favoring multi-phase processing including power making. In that case may bubble, droplet, film formation or movement, surface flows, these are the some features. Specialty that complex processes will be there, and also sometimes that products will be very precious, and also there may be functional chemicals that you can use for that synthesis. and in this case you will see some slow reactions or process will be there, and also there are several demands for that laminar flow post processing just by delaying loop in this particular external numbering up. Whereas you can handle that hazardous processes also by this external numbering up system, whereas in case of internal numbering system high degree of parallelism you can get compared to that external numbering up. Also internal numbering up, it has advantages over that external numbering up, because here favoring single phase processing there, whereas it may give that unit operations of standard reactions, and also it may be fast reactions that may be processes, no demand for laminar flow post processing process, even completed within devices you can say, and also safe processor also, since you are using one single device with that conjugated with several number of parallel channels conjugation. Now, here you will see there are several micro C based reactor for low chemistry flow chemistry there. For the chemical synthesis, there are several micro reactors are being used for getting that higher yield of that process synthesis, and it is advantageous because it may give that environmental benefits, it may give the economic benefits, it may give that chemistry benefits, safety benefits also, and ultimately this micro reactor technology with this flow chemistry in the micro reactor, that it will give you that ultimate you can say that green chemistry, where that environmental benefits, economical benefits, even safety benefits you can expect to get. So, this type of micro C based reactor with the flow chemistry for chemical synthesis, it will be beneficial for that green chemistry. Some commercially available flow chemistry also are there, like here it is given in the slides. Please go through these slides, that you can have some idea where that this different types of chemical synthesis in different types of micro reactors for that chemical process synthesis are being done commercially. Now, a question is that we know that micro reactor, how it is being defined, and also what is that microprocess technology, how it is being actually differed from that micro reactor, all these things. Now, interest is that we have to apply all those things micro reactor for different chemical engineering process or other other micro process systems. So, they are and day by day this application of this or research on this micro technology or micro reactor systems or microprocess technologies are gaining to the scientific and academic communities. And the chemical process, even new chemistry in micro channels enable, you will see that laboratory scale studies of large depth, large flexibility and notable fastness in gaining information. That is why the research is going on every day, even every month you can issue of several journals related to these topics of process intensifications are published, and how we can say that that interest is growing up day by day, because it gives that several advantages over that conventional processes, basically in the green chemistry system, because nowadays that world is growing fast. In that case we have to develop the process in such way that will be more sustainable, more greenery, more economic, even in that case more safety in issue. So, that is why this the interest is growing up day by day in this this microprocess technology there, to get that efficient way of process, even more yield, more that intensification of the process. Now, what are the advantages of that micro reactor, that we have to know, that based on which that maybe that interest is growing up day by day. Now, the length scale of the diffusion processes is in that case comparable to that of micro channels or even shorter. So, this is one aspect. Even you can get the efficient mixing of the reactants that can be achieved during very short times, typically milliseconds. Enhanced heat transfer due to the large surface area to volume ratio, and also enhanced mass transfer there. Also you can get that good heat transfer properties that allow a precise temperature control of reactions. And also you will see that there will be a heat transfer and mass transfer that will be more rapid in this micro channel based reactor there. Also you can get that continuous production by using this micro reactor technology that meets throughput requirements by either scaling out, that is stacking large of micro reactors, or by numbering up micro reactors parallelization. And also it is possible to change the temperature of microstructure reactors very rapidly to internally achieve a non isothermal behavior. And desired total productivity can be also obtained simply by a linear increase of productivity of individual micro reactors, even circumventing the conventional scaling up problems there. And the small hold up reduces the damage potential of explosions or other hazardous states of maloperations there. Even you can get that operation at the kinetic limit, not superimposed by the transport phenomena, that may allows one to reach high space time yields, so that the compact reactors and plants result. And selectivity is increased by suppressing the side reactions and by additional effect of precise setting of residence time, the content of follow up reactions that can be reduced there. Also other advantages like these small dimensions can prevent that explosions intrinsically. And also you can say that the symmetry based reactor design, that is NL to plate to stack to multitude of stacks, and the flexibility in operation that provide a high degree of modularity to adjust that production time, and also production rate, and bridging to the process system engineering. Now, for that direction in chemical process intensification, actually the aim of that microprocess engineering is not primarily to miniaturize that production plants, but you can say that it may utilize to that increase yields and also selectivities of the chemical reactions, and also you can use this for the reduction of the cost of chemical production. So, the main aim of that microprocess engineering is to that miniaturize the production plants, increase yields, selectivities, and also reducing the cost of the chemical production. And this can be achieved by either using chemical reactions that cannot be conducted in large larger volumina, or by you can say running chemical reactions at parameters like temperature, pressure, concentrations that are inaccessible in larger volumina due to the safety constraints. Now, the small geometric dimensions that may result in an intensified mass and heat transfer, which often leads to increase that yield and selectivity that is compared to the classical batch operation. Now, various in this case dynamic features to be considered when you will apply this micro reaction technology. Now, what are those dynamic features with the physicochemical requirements of the reaction that should be considered? In that case, what should be the relation of that reaction rate with mixing rate, even relation in mechanism with flow pattern, even relation of reaction time with residence time, even relation of exothermicity with the heat transfer in this that intensified way of heat and mass transfer in microprocess technology. Now, what are the dimensions of process intensification in microreactors? There are several aspects of that process intensification in the microreactors. Now, it may be that increased yields and selectivities based on increased reaction times, maybe based on reaction rates, maybe based on that some safety issues, some that economic consideration, even whether it is eco-friendly or not, different aspects of process intensification in the microreactors that is to be considered. Like that if you are considering that increased yields and selectivities, then increased yields and selectivities are directly tangible to green improvements in chemistry when using microprocess technology for the process intensification. And in the case of increased reaction rates, you can say that there will be some step change in increases in reaction rates, which come from increase in temperature, pressure or concentration. And also the simplification of the process flow you can get by the following manner, like this here given in the slides. First, you have to consider the simultaneous carrying out of the process steps such as multiple reactant dosing, even how it will be function, whether it will be integrating way or only single just entity there. So, generally integration process is more favorable for that process intensification. In that case, combination of the reaction and separation will be done there. So, that is why the simplification of the process can be done by integrating the system, like for the combination of reaction as well as separation. Now, reducing of downstream expenditure, even energy efforts to the better upstream performance are also those factors that can be considered for the simplification of the process flow in that microprocess technology. Now, accessibility of exothermic and thermal runaway reactions are also important factors that to be considered for the process intensification in microprocess technology. In that case, fast and exothermic reactions which leads to the formation of undesired products that can be controlled in the microreactor by hotspot assessment. So, you have to consider that reactions in such way that whatever heat is coming out, that should be utilized in different way, and also it may be controlled in such way that it may be distributed throughout the reactor just by having that that intensified way of the flow characteristics through the channel based reactor. And also increased safety to be also considered in this process intensification with this microreactor system. So, in that case, microreactors may allow a reduction of the risk potential when dealing with the toxic or explosive reagents, which makes formally unscalable reactions accessible to further development there. Now, this microprocess technology for the process intensification, another important dimensions to be considered, like how to increase that efficiency by less input and waste. So, in that case, the major portion of the waste in a chemical reaction is the solvent, which typically constitutes that 90% or more of the overall mixture, and these microreactors that also allow want to reduce that content of the solvent by increasing the concentration of the reactants. Also, you can say that the efficiency can be increased in terms of low volume optimization in the microreactor, even online reaction monitoring, elimination of the scale up, or multiple transformations that can also be considered for that process intensification based on that low volume optimization, even the online reaction monitoring. Now, what are the aspects of that implementation of that process intensification? What are the things that you can implement for the process intensification? Now, for increasing the mass transfer of the gas liquid reaction, that is one aspect of the implementation of the process intensification. How to improve that mass transfer via the large gas liquid interface, that is also another aspect. Now, changing the reaction mechanism through the solubility effects, that also can be done in the reactor for getting that process intensification. Also, using that steric effects, that is volume of transition state, to guide product and isomer selectivity. and also you can get that process intensification by pressurized high temperature operation. We will discuss more about that high pressure and high temperature system for the application of the reaction in the microreactor system in the next lectures, and also the changing the product types using high pressure and temperature. Also there will be a certain influence of the pressure on the speeding up of the chemical reactions, and in that case increase in rate constants by changing in activation energy and also pre-exponential factor based on that temperature effect, and the use of high pressure to exploit steric effects by the that volume of the transition state. So, these are the several aspects of that implementation for that process intensification in the microreactor technology there. So, we have discussed something that process intensification direction in the microreactor technology, and what is that microreactor and how it can be that assessed based on that different process intensification directions that already we have discussed. So, we have given some introductory that information of that microreactor system. We will discuss more about that microreactor system with some applications in different chemical engineering processes where we can apply this microreactor system for intensification of the process. So, I would suggest you to go further about this microreactor system to know more about that microreactor system, even microprocess technology system. Basically, you can go through this last references here, Hessel in 2005 the books, that is chemical microprocess engineering, processing and plants. I think these books will be more helpful for that getting more information about the microprocess technology. So, thank you for your attention.